we're going through answers to graphing variations of functions. So for y equals 1 over f of x, first things first, anywhere that the original has an x-intercept, the transformed function, the reciprocal, has a vertical asymptote. All right, next, the reciprocal of negative is negative, and positive is positive, and negative is negative. So the asymptotes have split the function into three parts. The reciprocal of big values is a small value, so it's kind of like that, and the reciprocal of a small value is a big value. So what we get is this behavior. Okay, next, this part is strictly between 0 and 1. 1 is a special value, so the reciprocal of 1 is 1. So that means that that is a point on our reciprocal graph. And as I said before, the reciprocal of positive is positive, so we're only operating in this area here. And we have these asymptotes, so it's going to look like this, because once again, the reciprocal of small is large. The reciprocal of small is large, right? So it's kind of like that. And there we go. Okay, that could have met that point a bit better, but you get the idea. And then into the third part, this is all negative here, so we're operating only in this space. Nothing will be up here. Now we have an asymptote here at y equals -3 that did not apply over here. So normally any function that we can write down is not going to behave like this, but this is just a graph that's being put together, maybe piecewise, for us to practice. So the original has an asymptote at y equals -3. Well, the reciprocal of that is -1/3. So I'll put an asymptote in here at y equals -1/3. And so think of it this way. As the original approaches -3, then the reciprocal approaches -1/3. Now have a think about why it's on this side, not on this side, right? Now here we've got small value, so the reciprocal of small is large, right? This sort of thing. But then it's going to approach this rather than approaching the x-axis like it did over here, right? Approaching the x-axis is a normal sort of thing, but that's when the original is heading off to infinity. Here, the original's not heading off to infinity, it's heading to -3. So the reciprocal heads to -1/3. So we have this kind of behavior, right? Now note that I'm drawing it carefully, okay? I've seen some people, once they get the idea, they think they can just sort of throw anything on the page. That's not true at all. You need to spend a bit of time showing the asymptotic behavior carefully. Right, that's that one. On to the next one. So we've got asymptotes here. Right, now this is once again reaching a height of 1. So we can put that in pretty easily. And here, that's just heading off to infinity, so the reciprocal will do this. So I can put that in. And on the other side, well, this part's approaching -2, so the reciprocal is going to approach -½ Now we've got a detailed y scale here, so we need to get that correct. And we get this behavior. Now, there's something I can do that's a bit more detailed with this part and this part. Okay, I can't do anything better with that. That's fine. But I'm going to rub these two out and just do them a little bit more detailed, right? Because -1 is an important value. So here and here are where the y values are -1. And so the reciprocal of -1 is -1. So we know that our curve goes through there. Now, are you expected to show that detail in an exam? Well, I think yes. Right. So if it's a hard question with a lot going on, then you might get away without that detail. But I think you should expect to have to show that detail. But this one is, once again, two asymptotes, two vertical asymptotes. Now, we're not told how far down that goes. Just to make it interesting, I'm going to put a -2 there. So I'm adding to the question here. Once I've finished it, I'll talk about what we can do without adding to the question. Now, this part's easy, okay? It's all positive. This part's easy, it's all positive, all right? The reciprocal of large is small, and the reciprocal of small is large. Now, here, well, it's going to be like that, but I guess the question is it like that, or like that, or like that, right? So I've added a -2, so when the original reaches a height of -2, the reciprocal reaches a height of -1/2. So it's going to be like that. And if you are given that information, you absolutely have to show it. So this would be 1, -1/2. Okay, now, of course, in this particular graph, we weren't given that information. So any one of these could be correct, right? And from the scale, it seems likely that this would be a -1. Anyway, I just wanted that to be a discussion point. All right, next one. So we have vertical asymptote, vertical asymptote. We have here clearly this doesn't go all the way down to -1. That, to me, looks like about -1/3, and the reciprocal of that's -3. So if we put a -2, -3 here, then this is going to be like that. Right, now, I don't think -1/3 is very accurate for that, but it doesn't look like it goes all the way down to -1/2 either. So if that is a bit more than -1/3, then this would go up a bit further, but only a little bit further. Okay, so we've got 1, 2, 3 sections to this. We've got y equals 1. The reciprocal of 1 is 1. So as the original approaches 1, the reciprocal will also approach 1, but it'll approach 1 from above, like that. I'm not putting arrows on my graphs, but you should. So the reciprocal of teeny tiny is huge. The reciprocal of 1 is 1. The reciprocal of nearly 1 is nearly 1, but it's got to be on the other side of the 1, right? 1 over something always produces something on the other side of the 1. So we know that this is an asymptote. We know that this is positive. So it's got to be up here, not down here. So this is the only way it can look. There's no reason for it to cross the asymptote and go from underneath. Some graphs do that, but there's no reason for that to happen here. And yeah, the reciprocal of that has to be on the other side of 1. So that's the only thing it can look like. Okay, and the third one, what are we going to do here? Well, so all of that is positive. So really, this is just going to be like that again. Well, that was terrible. It's just going to be like that again, but we have enough information to know that it goes through here, so we have to include that. Okay, so asymptotic there and asymptotic to the x-axis because the reciprocal of huge is teeny. Okay, so that's done. What have we got here? We've got asymptotes. We've got a y value of -1. Well, the reciprocal of -1 is -1, so it goes through there. We've got an interesting shape here, right? The way that turns around. So what's that going to do for us? Okay, well, let's just get the easy part out of the way. That has a y value of 1. The reciprocal of 1 is 1. So I can get that easy part out of the way. This one, well, it's really going to look like this. I think the only difference from other ones, right, is that this one, that's a symmetrical graph, so this will be symmetrical. That's fairly symmetrical, so this would be fairly symmetrical. This one's clearly not. So this would probably be something like that, not very symmetrical. You can't expect too much detail in that, but yeah, just something to think about. And here, well, that's heading off to infinity, so our reciprocal will go to 0, but it's all negative, so it's down here, so nothing happens up here. So that just looks like that. All right, so we don't always get, like, we often get this sort of alternating thing, which has happened here, 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 and here, alternating positive and negative. Here's an example where we've got negative, negative, positive, just because the original graph is negative, negative, positive. Okay, last one for this page. Right, we have a height of 1, so the reciprocal goes through there. We have a 0 here, so we've got a vertical asymptote. Okay, now this is approaching 0, so the reciprocal will approach infinity. So we know it goes through there, and we know it approaches infinity, but whether it goes as like in a straightish line, or an upish line, or even a line like that, I can't tell. So let's come back to that. What about this part? Well, that, once again, I'm just saying the absolute basic things. The reciprocal of teeny tiny is huge. So it sort of comes down like that and meets the point that we know is on it. So we've got that, and then anyone's guess what happens here, so you can't be wrong. And then this part here, well, that's just negative, and that's no different from like that negative or that negative, whatever, okay? Same sort of thing. Although it looks like maybe, I think we're expected to believe that the y-axis is an asymptote for this. That's my interpretation. So that would mean, okay, it's more interesting for us to say that it is. So if I just sort of continue the y-axis down here, if that's just sort of, that's going off to negative infinity, right? So if the original, so if f of x approaches negative infinity, well then the reciprocal approaches 0. But just like this never gets to negative infinity, this never gets to 0. And so what we've got is an open circle here, and then that behaviour. Okay, so we haven't encountered it much, maybe not at all. So you need to take special note of this, right? So if we're taking the reciprocal of a graph that's heading to infinity but is bound like this, then it can't actually, the reciprocal of this can't actually reach 0. Just like here, the reciprocal never reaches 0. It approaches 0 but never reaches it. Well, this approaches 0 but never reaches it. It's just that nothing happens over here. Okay, so that's the end of the first video.